Wild race to build a real quantum computer. Microsoft just dropped an announcement that sounds like it was pulled straight out of a sci-fi movie. We're talking about creating a new state of matter and building a machine more powerful than every computer on Earth combined. So what is actually going on here?
And bam, the headlines just exploded. First up, Reuters basically says, hey, that quantum future we all thought was decades away, it might just be a few years off now. Then the New York Times jumps in, and they double down on the sci-fi angle. I mean, listen to this. Creating an entirely new state of matter. We're not just talking about a faster chip here. But wait, it gets even crazier. The biggest, most mind-blowing claim came from Microsoft themselves. A machine more powerful than every single computer on this planet combined. Just let that sink in for a second. All right, so let's get to the bottom of this. This all revolves around a chip that Microsoft announced in February 2025, a little thing called the Majorana 1. And that's the big question we're going to unpack right now. Is this a genuine world-changing breakthrough, or is it just some incredibly brilliant marketing? To really get what Microsoft is claiming, we need a little bit of background. We've got to talk about the one massive, gigantic problem that's been holding back quantum computing for decades. Seriously, this is like the holy grail of the entire field. So, you know how the computer or phone you're watching this on works, right? It's all based on bits, and those bits are super simple. They're either a 0 or a 1, on or off. Super reliable. But quantum bits, or qubits, they're a whole other level. They can be a 0, a 1, or, and this is the magic part, both at the same time. That's where all the power comes from. But it's also their biggest weakness. They're unbelievably fragile, just finite. And there's a villain in this story. It's a pesky little thing called decoherence. The best way to think about it is like static on an old radio. The tiniest little thing, a bit of heat, a tiny vibration, can just wash over the qubit and poof, your whole calculation is gone, ruined. This right here is why building one of these things is so ridiculously difficult. So for years and years, scientists have had this dream, this theoretical solution called a topological qubit. The idea is brilliant. Instead of storing information in some fragile state that can just disappear, what if you could store it in its shape? It's kind of like tying a knot in a rope. You can shake that rope all you want, but the knot is still there, right? A topological qubit would work the same way. It would be naturally protected from all that noise we were just talking about. And guess what? That holy grail, that almost mythical idea, that's exactly what Microsoft has been betting the farm on for more than 10 years. It's a huge, high-risk, high-reward gamble, and it's what led them straight to this new chip, the Majorana 1. You know, this quote from one of their top scientists, Chetan Nayak, really says it all. He said, "We took a step back and said, okay, let's invent the transistor for the quantum age." Think about that. They're not just trying to build a better quantum computer, they're trying to invent the fundamental piece, the quantum version of the transistor that will power everything in the future. That's some serious ambition. So what's at the core of this whole plan? It's something straight out of theoretical physics called a Majorana zero mode. And get this, it's not even a real particle. It's a quasi-particle, which is basically a fancy way of saying it's an illusion, a ghost, created by a bunch of electrons all acting together in just the right way. It was dreamed up on paper back in 1937, never actually found in nature. Microsoft's whole bet is that they can create and control these things. Okay, so how on earth do they do it? Well, step one, they literally build a new type of material, one atom at a time. It's insane. Step two, they use this stuff to conjure up those ghostly Majorana particles. Step three, they trap them in a little H-shaped circuit. And now for the part that just breaks my brain. To do a calculation, they physically braid these particles around each other. The answer to the problem is literally encoded in the pattern of the braid. Wild, right? I know, this sounds absolutely amazing. Like game-changingly amazing. Almost too good to be true. And, well, that's where things start to get a little bit messy. Because a lot of people in the scientific community are looking at these huge claims and saying, hold on a sec. And look, this skepticism isn't coming out of nowhere. There's a bit of history here. See, back in 2018, Microsoft put out this huge paper in a major journal saying they'd found evidence of these particles. But then, in 2021, that paper got retracted, pulled. Other scientists took a look and said the data just wasn't solid enough. So you can see why the community is giving this new announcement some serious side-eye. And here's the real kicker. If you actually look past the marketing and read the scientific paper they published, there's a gap, a big one. The PR team is shouting, "We confirm the particles," but the paper says, well, the evidence do not by themselves determine if they're the special topological kind we need. They call it the world's first QPU, but they didn't actually process anything. It was more about reading the state of the device.
In fact, you don't have to take my word for it. One of the official peer reviewers, the expert whose job it is to check the science before it gets published, put it perfectly. They basically said, look, the big deal here isn't that they proved the physics. It's that they came up with some cool new ways to build the thing. And that, my friends, is a huge, huge difference. So what's the actual scientific problem here? The best way to think of it is they're trying to find one specific needle in a haystack of identical-looking needles. The real Majorana particle they need gives off a signal that looks almost exactly the same as a totally useless imposter particle. Microsoft is saying, we found the magic needle, but a lot of other experts are saying, are you sure you didn't just find another piece of hay? And that's really the core of the debate. Okay, let's take a breath. We've got the huge hype on one side and some pretty serious scientific skepticism on the other. So, where does that leave us? What should we actually take away from all this? Well, here's one thing that is not up for debate. Even the biggest skeptics agree that this chip is a flat-out masterpiece of engineering. Forget the physics for a second. Just being able to build and control something this complex at this tiny scale is a huge win. It's a major step forward, no matter what. And that brings us to the number that everyone in this field is obsessed with. 1 million. The general thinking is to do anything truly useful, to solve problems that actually matter to businesses and society, you're going to need a quantum computer with at least 1 million good, stable qubits. And if we ever get there, 1 million quantum machine? Oh man, the possibilities are just staggering. We're talking about designing custom molecules that could eat microplastics in the ocean, creating new materials for bridges or phones that can literally heal themselves, discovering new medicines in a fraction of the time. We could even have an AI that understands the language of nature and can design the perfect material for any job on the first try. It's world-changing stuff. There's actually a name for this ultimate goal. The physicist John Preskill calls it the megaquap machine. It's a computer that can perform at least 1 million reliable quantum operations. That's the real finish line everyone is racing towards. Getting there marks the real beginning of the quantum age. And it's so important to remember, Microsoft's all-or-nothing approach is just one horse in a very crowded race. You've got giants like Google and IBM who are taking very different, maybe more traditional paths to get there. It is a full-on global sprint, with everyone gunning for that million-qubit horizon. And that brings us right back to where we started. Is Microsoft's huge, high-risk, super controversial gamble going to be the thing that finally unlocks the quantum future? Or will we look back on this as another fascinating chapter, another false dawn, in what is probably the single hardest tech race humanity has ever run?